Pressure. Something Freddie Mercury sang about, something we're going to talk about in chemistry in just a few seconds. Get ready. Here we go. All right, just a few things that I wanted to talk to you guys about before we're ready to take our final quiz on our gas laws unit. It's going to be some more review for you, like it's been the last couple of days, but still want to make sure we get a good assessment on this. So you can see on my screen here, I've got something that should look a bit familiar to you. One of the ways we can simulate gas particles moving around and doing all the things that gas particles do and be able to see it on our screens here. So going way back to the beginning, in the beginning of this video, we talked a little bit about pressure, and I want to make sure that we understand the idea of pressure, which is caused by the collisions of particles with the sides of the container. All right, that's one thing we have to make sure we always understand. Pressure is equivalent to those collisions with the side of the container. So as we look at something like this, there are 50 particles, 50 heavy particles and 50 light particles. You can see that over here. Because the number of particles are the same, both of these gases are contributing equal amounts of pressure. If I were to change that, let's say I remove some of the light particles. Let's take a whole bunch of them out of here, go down to about 25 or so. So there's half as many light particles as there are heavy particles, then the light particles would be contributing half the pressure of those heavy particles. All right, so it's always related to those two. If we looked at the partial pressures of each of those, remember we have that Dalton's law of partial pressures, which says that the total pressure of the gases in a container is the sum of the individual pressures of each gas, or the sum of the partial pressures of each gas. So something to keep in mind as we get ready to wrap this unit up. Okay, and we could change this around and do a whole bunch of things with that. I'll put a link for this in Classroom, and you can go play around with it if you want. We've done a bunch with that already, but it's been a little bit of time, and you might want to refresh it. All right, let's kind of get everything back to being equal. All right, so we've got 50 and 50. If we look at these, another property we could look at in terms of the particles here would be the kinetic energy. And if we were to try to figure out which of these particles had more kinetic energy, that's one of those trick questions, because kinetic energy should be synonymous with temperature. And we can see in here that the temperature is not changing, or the temperature is constant, so all the particles are at the same temperature. Therefore, they have the exact same kinetic energy. Don't fall for that trick. All right, if you see a question like that, if gases are in the same container, they have the same kinetic energy. Finally, one of the things that we could talk about would be density, determining the density of the gases in here. And we can see, because they have the same number of particles, qualitatively speaking, we would say that the heavy particles are more dense than the light particles. And the way we can say that, or the reason we can say that, is because the equation for density is mass divided by volume. Okay, so if I know the mass of the particles divided by the volume of the container, that will give me the density. Because we have equal numbers of particles here, the heavier ones have a greater mass, therefore the density would also be greater. All right. In some problems, you may be given a number of moles and a volume of a container. You can still calculate the density of that by first converting the moles into mass and then dividing by the volume. Okay, so pretty straightforward calculations. We've had some practice with that in the past. You had some problems in your packet a little bit earlier. If you want to go back and review some of those, you are welcome to do that. All right. I think that's all I wanted to review today. We should be in pretty good shape. We'll have a short quiz coming your way. Again, a Google form. You guys have been doing an awesome job of getting those quizzes taken care of, and you're doing a good job when you're taking them. Okay. If you have questions, please feel free to shoot me an email or leave a comment in Classroom. We'll try to get back to you as soon as possible. All right. Have a great day, you guys. Take it easy.